My dear students, uh, today today we'll discuss few more concepts related to that is Fourier series representation of periodic signals. That is, we have discussed almost all concepts which are there in the third module. Some concepts we have not discussed in the third module about Fourier representation of periodic signal is that how we can represent the signal in the form of Fourier series. That is, we know that we can represent the signals in the form of Fourier series. There are different types of representation of Fourier series. That is about that is trigonometric Fourier series representation. That in compact Fourier, that is trigonometric Fourier series. That is the types of Fourier series. Depending upon the representation, these are the types of Fourier series: trigonometric Fourier series, compact trigonometric Fourier series, or polar Fourier series, and exponential Fourier series. We can represent a signal Fourier series to analyze. Here you see this purpose. Fourier series are used to analyze periodic signal. Suppose some signal is periodic, then with a Fourier series we can analyze the signal. Why we have to do the Fourier series? This, to analyze the signal, whether the signal, how much the how is the quality of the signal, how much is the signal is there, how much is the noise is there, how much is the distortion is there. Here they are written. The harmonious content of the signal is analyzed with the help of Fourier series. Fourier series can be developed for continuous time as well as discrete time signals. Some harmonics will be there, some distortion, harmonic, some distortion, which are there in the signal that can be analyzed by using the concept of Fourier series. Fourier series, suppose signal is there. Periodic signal, you know that what are different types of periodic signals? What do you mean by periodic signals? Signals which repeats at regular intervals of time are called as periodic signals. And aperiodic signal or non-periodic signals are the signals which will not repeat at regular intervals of time are called as non-periodic signals. For example, periodic signal, sine wave, cosine wave, triangular wave, square wave, all are these are periodic signals. Non-periodic signals, exponentially increasing signal, exponential decreasing signal. So many different signals. These are example of non-periodic signals. Therefore, here for periodic signal, for communication, suppose mobile communication is supposed to take. Suppose I'm using mobile communication to communicate one of our friend, one of our relatives. At that time, when some person may be here in another district, another state, another country, when we make the communication, when we make a call, where there is connection established between from me to one of my friend or the relatives. At that time, whatever I talk, whatever I give the information, that will be successfully transmitted to the receiver. The quality of the receiver should be whatever I'm talking, that should be received successfully with the receiver. So suppose some disturbance is there, some noise is there. At that time, what I'm talking, that will be not clearly heard by the receiver, because noise is added, some harmonics are added, some disturbance are added. By analyzing, by using the concept of Fourier series, we can analyze how much is the signal is there in the how much information is there in the signal, how much is the noise, how much harmonics. Therefore, this all concept Fourier series, for since from so many years, 50, 60 years, they are doing research day by day. There is a there is improvement in the technology of signal system. Day by day there is a improvement, there is a revolution. Day by day there is advancement in the field of signal system. Therefore, using the concept of a trigonometric Fourier series, or using we can analyze the signal, the periodic signal, analyze the periodic signal. There are different types of analyzing the periodic signal. That is, here in Fourier series, we are having three different types of analysis of periodic signal. That is trigonometric Fourier series, compact trigonometric Fourier series, and exponential Fourier series. Already in the class we have discussed about for trigonometric Fourier series. This is already we have discussed with an example about the trigonometric Fourier series. Also with an example, we have found out the Fourier series for a signal using the concept of compact trigonometric Fourier series. And also one more technique is there to find out the Fourier series is that is exponential Fourier series. Here we are having to equations to find out the Fourier series. This is first one is called as synthesis equation. Second one is called as analysis equation. Now, with an example, we'll come to know how we'll find out the Fourier series of a signal. That is, with an example, we'll discuss in in class. I have covered all the concepts, but only I have not discussed about how we can find out the Fourier series using the concept of exponential Fourier series. This is also obtain the polar series form using compact trigonometric Fourier series, or also it is called as polar series. This I have discussed in the class, but I did not have time to discuss about the Fourier series using the concept of exponential Fourier series. Here, so in exam, sometimes they ask find out the Fourier series of signal using obtain the polar Fourier series. They have given the signal in figure 4.2.1 using concept of polar, means from using compact Fourier series only you have to solve this problem. Here you have to find out d of 0, d of k, pi of k, like this. Here in problem what they ask, using that method only you have to find out the solution. For example, here in this example 4.2.4, they asked you to find out the Fourier, obtain the exponential Fourier series for the signal of figure 4.2.1 and plot the magnitude and phase spectrum also. Here they have discussed about the trigonometric Fourier series and everything. They have discussed taking this example, one signal only. This is this is a periodic signal which repeats at regular intervals of time. In taking this only one signal, we have found out how we can find the Fourier series using the concept of Fourier series. Here, where here you see here, here find trigonometric Fourier series for the periodic signal in figure. In figure, what is a periodic signal? They have given here. We find the trigonometric Fourier series. Here in trigonometric Fourier series, we have to calculate what is a of 0, what is a of k, what is b of k, what is b of everything. We have to calculate here. Then only we'll obtain the Fourier series of signal x of t. Then place the values of a of 0, a of k, b of k in this equation. We'll get this is the Fourier series of x of t using the concept of trigonometric Fourier series. Then same equation, same figure. That is what you see here. Figure number 4.2.1, periodic exponential pulse. It is represented by e raised to minus t. It is also periodic signal because it is repeating it. Its format, it is pattern at regular intervals of time with a time period of t equals 0. Because in between this interval, it is repeating a particular wave, a particular signal. Therefore, it is a periodic. Therefore, using this technique, we have found out this one. Using the polar 4, here also, you see here, figure number 4.2.1. Obtain the polar Fourier series for signal of figure 4.2.1. Here also you see here, the same signal we can analyze using the concept of polar Fourier series. In polar Fourier series, what we have to do? We have to find out what is d of 0, d of k, pi of k. Then we will get the expression like this. Then we'll now this we have not discussed in the class. That is what obtain exponential Fourier series for the signal. Here also the figure number 4.2.1 for means same signal 4.2.1 figure number 4.2.1 same signal. Will find out the Fourier series using the concept of exponential Fourier series. Then here how we can find out the plot and obtain exponential Fourier series for the signal of figure 4.2.1. Plot the magnitude and phase spectrum also. Here they have given in figure, they have given particular signal. In a they may ask different they may give different in exams. They may give different signal, ask you to find out the Fourier's exponential Fourier series of that signal. Method will be same, but only there is change in the signal. Therefore, for example point of view, we have to refer three or four questions related to this exponential series. These 3 to 4 questions related to the polar Fourier series, 3 to 4 questions related to trigonometric. Like this, you have to methods will be same, equations will be same. Only there is change in the signal. Then now we will find out how we can find out the Fourier series of a equation that is of a signal that is x of t. Therefore, what are the different steps? That is solution. Step number 1, to obtain x of k. X of k, that is Fourier series of the signal x of t. That is nothing but we can represent as by equation x of k equal to 1 by t integration of t x of t e raised to minus jk omega naught t dt. This is the equation to find out x of k. Here omega naught equal to 2 pi by t. Here t is time period, as I know that the time taken to complete one cycle for that e raised to minus t signal is 0.5. Already they have mentioned here, they have in the signal they have mentioned. What is that 0. Signal is repeating its pattern at interval of 0 to 0.5. Therefore, time period we have to consider as 0.5. Therefore, we know that omega equal to 2 pi f. F is inversely proportional to t. Therefore, we can write omega naught equal to 2 pi by t. Therefore, it is equal to 2 pi by 0.5. Then it will be equal to 4 pi. And x of t, we know that the signal is represented by e raised to minus t for interval of time 0 to 0.5. Therefore, we can obtain x of k, substitute these values of 1 by t, x of t in this equation. These values 4 pi, e raised to minus t, everything substitute in this equation. Then we will get the Fourier series of x of k as x of k equal to 1 by 0.5 integration of t. Time period is, it is time limits are limits of integration is 0 to 0.5, and x of t is, this is x of t signal is represented by e raised to minus t. Then this is same as e raised to minus jk omega naught t. Here in place of omega naught we have to substitute 4 pi. Therefore, e raised to minus j k minus jk in place of omega naught we have to substitute 4 pi, t as it is, dt as it is. Then it is equal to, therefore 1 by 0.25 is nothing but it is equal to 2. Why? Because 0.5 means what? 1 by 2. So 1 by 2 means it is in the denominator. It is numerator, 1 is numerator, it is denominator, which is there in the denominator. Therefore, when it comes above, then it will be equal to 2. All basic mathematics. Okay, then integration 0 to 0.5. That is, here he has to write 0.5. Therefore, 2 integration 0 to t. Then rearrange this equation. Therefore, we will get that e raised to minus integration 0 to 0.5 e raised to minus into 1 plus j 4 pi k t dt. This is, we will get this one. Then after doing the integration, we will get this equation, that when we integrate this equation, we will get this equation, that is 2 into 1 point 2 into 1 by minus 1 by j 4 pi k into e raised to minus into in the bracket 1 plus j 4 pi k into t, and apply the limit 0 to 0.5. Like this, when you go on doing mathematics, applying limits and everything, you will get the expression for that is x of t equal to x of t. Here e raised to minus j 2 pi k is there, that we can write here some formulas. You require some formulas. No, that we can write as cos 2 pi k minus j sin 2 pi k equal to 1 always. Hence substitute this value in this equation. Suppose substitute value of e raised to minus here 1, then that's analyzing that one, we will get the x of k equal to 0.7869 divided by 1 plus j 4 pi k. This is what the Fourier series of a signal x of t. That is to express the next step is to express the exponential Fourier series. That is to express this is what x of k. To express the exponential series in the form of exponential Fourier series, putting x of k in synthesis equation of equation 4.2.3. Already told that we defined two equations in the exponential Fourier series. Here where exponential Fourier series, defining equations x of t, we can obtain x of t. This is called a synthesis equation. That is nothing but summation of k equal to minus into plus infinity x of k e raised to j k omega naught t. This is called a synthesis equation. And one more equation is that capital X of k equal to 1 by t integration t x of t e raised to minus j k omega naught t dt. This is called an analysis equation. From signal x of t, which is represented as signal is then this is Fourier series capital X of k. We can obtain like this using this equation. Suppose we want to find x of k, that is using this signal, we can find out like this. Therefore it is called as synthesis equation. It is called as analysis equation. Using the equation number also 4.2.3, using that number, that is what using that number we can find out the Fourier series of this signal. To express exponential Fourier series, putting x of k in synthesis equation of equation 4.2.3, then that will be x of t equal to summation x of k. X of k is what? X of k is this. X of k summation k equal to minus into plus infinity e raised to j k omega naught t. When we substitute the value of x of k in the synthesis equation of the exponential Fourier series. This is our Fourier series. That is what, to express exponential Fourier. This is our Fourier series. But in the problem, they are not only asked about to find out obtain the exponential Fourier series for the signal of figure 4.2.1, and also they are asked to find out plot the magnitude and phase spectrum also. Not only we have to obtain that is not over, we have to find out what is magnitude and phase spectrum also. Therefore some steps are required to find out the magnitude and phase of the signal x of k. Then that is third step, that is to obtain magnitude and phase spectrum of x of k. We have x of k equal to 0.7869 by 1.4 j 4 pi k by equation 4.2.18. This is here 4.2.18. This is equation of x of k. Here this is x of k. Take that x of k value by equation. Then here what we will do, 0.7869 divided by 1 plus j 4 pi k is there, no, we will multiply that by that, here 1 plus j is 1 plus j 4 pi k is there. Therefore what we'll do, we will multiply with 1 minus j, everything is same, only I will change the sign from plus to minus. Therefore 1 minus j 4 pi k into 1 minus j 4 pi k, because I am here on the numerator term side also I am multiplying, here also in the denominator side also multiplying. Therefore no change, it get cancels and we will get this same only. There is no change in the expression, only we are rearranging that equation. Therefore when we do like this, what happens here, we will get this expression. You will get this is multiplied by this, then you will get this equation. Then here in this equation you see here, but here when we here 0.7869 into this, therefore this divided by 1 plus 4 pi k square. I will write like this. I will separate these two equations, minus and j is there, j 10 minus j, this 0.7869 is common, therefore 0.7869 into 4 pi k. Here j, then this denominator is common to both the terms here. Therefore 1 plus 4 pi k square. You will get this equation. This is here in this equation. This is what we will consider this as a real part. Minus j, this part we will consider as a imaginary part. Then from that we will find out x of k. X of k is equal to, we will find out the magnitude, obtain the magnitude means that is we will for finding the magnitude we will like do that is nothing but x of k, modulus of x of, we have to write like this. This denotes this is the magnitude of x of k. To find out that one, what we have to do, that is here you see here, that is here here the whole term, what we have to do, we have to square, we have to do square we have to do square of this, squaring and multiplying, squaring and finding the square root, squaring and square root, therefore we will get the magnitude of x of k. Here you see here this equation is there, what we done, square like square, and this is square root, square and square root. Therefore from doing like that we'll get the magnitude of x of k. By doing so we'll get the expression for x of k as x of k equal to 0.7869 divided by 1 square root of 1 plus 4 pi k square. Like this we'll get the expression for magnitude of x of k. Then and phase spectrum, this is we got the magnitude of x of k. Now we'll find out the phase spectrum. Phase spectrum is given by angle of x of k equal to tan inverse of imaginary part of equation 4.2.19, where 4.2.19 in this equation. As I told, this is the real part, this is the imaginary part. Here imaginary part of equation 4.2.9, real part of equation 4.9. From that tan inverse of that we will get. Then when we substitute these values, at other time we will get the expression for angle of x of k, that is phase spectrum, equal to minus tan inverse of 4 pi k. When we substitute these values, the imaginary real value, imaginary values in this expression, this expression will When we substitute, then we'll get what? The phase spectrum, which is represented by minus tan inverse of 4 pi k. Therefore, then we'll prepare a table. There we mention about the values of magnitude. Here, following a table lists the calculation of x of k and angle x of k. Here we'll find out it is the calculation of the magnitude. It is the values of the phase values. For the values of k is minus 3, minus 2, minus 1, 0, 1, 2, 3, like this. From this we'll get from substituting the value of k here. Suppose in this expression I will put the value of k as minus 3. We'll get some value here. In this expression I will put the value of k as minus 2 here. Minus 2 means we'll get like this value. When in this expression I will substitute the value of k as minus 1, we'll get this value. Suppose in this expression I will substitute the value of k as 0, then we'll get this equation, this value. Like this, when we go on substituting the values of k, we'll get these values. Similarly, substituting the value of k in this equation, minus tan inverse of 4 pi k, but these values will be in terms of radians. Radians means in terms of angles. When we substitute the value of minus 3 in this equation, minus 2 in this equation, minus 1 in this equation, like this we'll get these values. Once we got these values, then we will plot a graph. That is what in x-axis, which represents the k, and the y-axis it represents x of a magnitude of x of k, then it is with respect to k. Here we'll take this is 0, 1, 2, 3, 4 values of k here, then 1, 2, 3, 4. We minus that also, minus 1, minus 2, minus 3, minus 4. Then for the minus 3, how much is the value? Minus 3, 0.028, 0. Here you see minus 3, how much? 0.0 here you see here. Minus 3, what is the value? 0.02 something or 8 is there. That will not take it seriously. That will not consider. Okay, 0 for minus 3 it is what? 0.02. Then for minus 2, how much? Minus 2, it is 0.03. Here you see minus 2. Here you see this is, here it is 0.2, but here it is 0.3 for minus 2. Minus 1, how much? 0.06. Now you see here for minus 1, this is minus 1, it is 0.06, the magnitude of x of k. Like this we will get the sequences like this. For 0, how much? For 0, how much is the magnitude? 0.7. 0.7 means when the value of at k is 0, here value of k is here 0. How much? 0.78. Here we'll get x of k here. This is one more sequence. Like we will go on substitute, we will get these values. This now we will get the sequences like this. This is what the magnitude spectrum, magnitude of x of k. And also when we substitute the values of this, that is minus 3 equal to 1.544, like this we'll get for minus 3. Minus 3, how much? That is what? 1.5. Here you see, this is here, this is 1. Therefore minus 3, it is here, it is 1. It is expression of phase spectrum. Minus 1, it is equal to 1.5. Here 1.5 means this is 1, this is 1.5. Then for minus 2, it is also nearly 1.5. Then for minus 1, it is 1.4. For 0, you see here, for 0, k value of k is 0. This is 0 only here, 0 only. 0. For minus 1, this is about minus values. Then 1 is what? Minus 1.4. Minus for 1, what is the value? It is in terms of minus. Minus means this is positive axis. This is negative axis. Negative is how much? Minus 1.4. 1.4. For minus 2, how much? For 2, how much? That is minus 1.5. Minus 1.5. Yours. This is minus 1.5. Then for 3, 3 means here it is x-axis positive. X-axis positive. Values are on the y-axis and towards the negative side. Therefore, 3 equal to minus 1.5. 3 equal to minus 1.5. Like this, we can substitute the values. Then this is what? This is your phase spectrum. We'll get the angle space spectrum for like this. This is phase spectrum. This is what? Magnitude spectrum of the signal of x of t, or the of x of k here. Yes, obtain the exponential Fourier series for signal and plot magnitude and phase spectrum also. This is, so you have to write all these things in the exam. Then only they will give good marks and you will get good marks. If suppose they ask such questions for 10 marks, 12 marks, like this they will ask. Definitely such questions will be asked in the exam. Okay. Okay, thank you.